on dictionaries, tuples, sets, and we've looked at all of that. And that is what we're using to build our machine learning model. So we started from first principle, and that is like the foundational knowledge you need for the journey ahead. So if you notice, many times when I was teaching, I was referring to docs, and that is how it usually is. Senior engineers at NVIDIA, at Google, they Google, or now they also consult ChatGPT or Reddit or Stack Overflow. And that is how it's going to be because there's always something new to learn. There's always something you didn't know. But you need to do your research, then apply it to your use case. There's almost nothing that is novel or new under the sun. Most of the programs you are seeing is code that was already available online that someone took and tailored to his or her use case. So let me start with that. So we've looked at how to build machine learning models. We've discussed concepts such as pandas, NumPy, importing the data that we're going to use, cleaning the data, exploratory data analysis, data visualization, then down to building models. Then we looked at things like terminologies like your um, feature variables and your target variable. And we looked at some models, we looked at decision tree and random forest regressor. So we've come a long way, and you just, I hope you guys can give yourself a pat on the back because I'm actually really proud of you guys, but also your commitment and showing up week in, week out. Okay, so we are going to, in the last class, we're looking at some more granular entry cases in machine learning. We've looked at concepts like overfitting, underfitting, and yes, we didn't look at data leakage. But basically, those are what the aim of this bootcamp was to get you started with machine learning and data science to give you um help you start your journey and also teach you in a way that we don't need to handle you when we when the program finishes. That was the aim of the bootcamp. So at this juncture, we believe that you are able to perform research on your own and apply that research to your use case, to the problem you are trying to solve. So I'm going to go into our business proper for today. But I just want to give this few bits of advice. So no matter what the problem is that you want to solve, just break it down into three main steps. What is the problem? What is the solution? And can it be solved by machine learning? So no matter where you find yourself, you can apply machine learning to almost anything. Almost anything. I'm a student of geoscience. I'm applying machine learning to modeling climatic conditions to help seismic acquisition. Seismic is a geophysical principle that they use in trying to find oil and gas that we use in everyday lives. So you can apply machine learning to anything. People are applying machine learning to fraud detection, to biomedical science. People are trying um to the health industry. People are trying to predict if a patient has heart disease or not, which spoiler alert to be looking at that today. People are trying to predict prices of something, whether a house, a model. People are so there are a lot of the limit is your imagination. So if you can properly frame your problem, right, and you can find a solution and see if you can apply machine learning to it, go for it. It's going to be a very, very rewarding journey. And I want you to know that the best way to learn is by doing. Learn by doing. It is a proven method of learning. So when you see something, don't get stuck in something that we call tutorial hell. There's someone that might be learning with tutorials for 2 to 3 years, and there might be someone that's been learning for 1 year but has been practicing building projects. I tell you for free, that person with 1 year experience is better than the guy with almost 3 years because he has been practicing. That thing has become you are what you know. The more you do something, the more you become better at it. First time you see, um, first time you're trying to learn how to drive, it looks so scary. But when you drive the first time, you drive the second time, you become an expert. So the more you practice, the better you become. So that is my some keynotes of advice I wanted to share with you guys. So moving down to our as we're rounding up the session, we are going to give you a project and it's going to be based on everything that we've done so far, but we want you to solve it. So I think maybe I'll allow you guys to vote on what you want to do. Let me not just dictate it, but we're going to be using Cargo to do a machine learning project. But before I go into that, let me share my screen. Share. All right. Please kindly confirm that you can see my screen.
I can't.
Yes, you can.
All right. Thank you. Thank you. So now, just like we mentioned, so this is an hypothetical scenario, and this data set is gotten from Cargo. Okay, so I want to change the way I'm sharing my screen. I want to share my entire screen so that you can just follow me wherever I'm going. I don't think I have any confidential data open.
Right, this is a safe place.
It's not about safe space. In the data world, there's something called data privacy. People have some data that you are using must not be shown to other people unless you find yourself in prison. I have friends who have been that's a topic for another day. But data privacy is a very big thing because people want to there's data privacy, data anonymity. People are trying to anonymize that data. They don't want to know the people that got that data from. Data privacy is actually a very big field in data space now. All these competitors, they don't want people to have access to their data so that they can build something that is better than them. And if you are working for a company, right? If you're working for a company, they won't want you to be showing their data to everybody. It's Nigerian companies, they might not put much emphasis on it, but abroad companies, they will see you. So it's not a safe place, please. Prison is not a safe place. What is this now? Why is it doing like this to me today? Okay. So over here we have, should we start with regression or classification? I'm going to give a very high level overview. No, let me not answer that question. I will ask people that question. All right. Okay, we'll come back to this one later. So we are trying to predict the sale price of bulldozers using machine learning. What kind of problem do you think this is? We are trying to predict the price of bulldozers using machine learning. What kind of problem do you think this is?
Regression.
Yes, it's regression. You are trying to predict a value, a number. Anytime you're trying to predict continuous variables, numerical variables, most of the time dealing with the regression problem. All right. So this notebook is very well, should I say, documented so that you understand. That's why I sent it to the group. But here I divided into 5 phases. Where is model building? Okay. So problem definition. How well can we predict the sale price of a bulldozer given its characteristics and previous examples of how much similar bulldozers have been sold for? And yeah, the data was gotten from Cargo. Smoking. Yep. Blue book for bulldozer. This is the data gotten from Cargo. That it has the train validation and test data sets. Says that at 123.28 MB. All right, so that's where the data was getting from. I'm about to do it. This is what I was saying about confidentiality. You know why my laptop is doing this to me today. All right, so that is where I got the data from. So we have the train.csv, which are historical bulldozer sales up to 2011, close to 400,000 examples with 50 plus different attributes. Now, an attribute is the same thing as your input variables, right? But this 50 plus is including the sale price, which is our target variable. Then the validation data is now from 2012 to April 2012, January to April 2012, 12,000 examples. The testing data is from uh, May 1, 2012 to November 2012. And this is what you'll be trying to predict. So you use this your train and validation data to train your model, build your model. Then you now test that your model on the test.csv. Since we are doing with a regression problem, the evaluation metrics we employ are metrics like RMLSE, root mean square error, and but the best one for this problem is we're using root mean squared log error. The goal will be to get the value of this as low as possible, as close to zero as possible. Now, root mean, all these errors have different, um, let's say, applications depending on your use case. So when you do root mean or mean average error, that is the average. But if you know that larger errors, or you want to put more constraint on your error, so paraventure, you're trying to predict the price of a commodity. You are working in a supermarket, you want to predict prices of products that remain a competitive edge and does not lose the money for the business. And if you go and predict prices that are too far apart, it is not the best thing. It's not the best course of action. You have to predict prices that are within a particular range or interval. So you want to penalize all those ones that are so far away. That's why we're using squared error, mean squared error. Or if it's something that the range, the level of variability doesn't really matter, you can still stick with your normal MA and the rest. But it's even good to have all of them to have a very robust set of evaluation metrics. So your RMLSE, your MSE, mean square error, mean average error, RMSE, have all of them. That is the best course of action. All right, so we explained all of this. So because of time, this is me importing all the libraries that we'll need. NumPy as NP, Pandas as PD, Matplotlib, .pyplot as PLT, and sklearn. And this is me importing the training and validation sets. And this is looking at it, having a general overview using df.info. You see that there are 52 attributes, like mentioned when we checked cargo. Then now this is checking for columns with missing values. Now you can see how many. This is brother, auctioneer ID, 20,136. This one is even worse. 265,194 missing values. Now, how do we approach this? What do we do? Because this is how the reality is in real life. The data sets we looked at before when we were looking at intro to machine learning, there was no missing value. Everything is straightforward. Just plug it into your model and start building, and everybody goes on happy. That's not the case in real life. In real life, there are a lot of inconsistencies in your data, and there's a lot of missing values. And remember, machine learning is garbage in, garbage out. So if you give it poor data, it will give you very poor results, and that will affect the business. So there has to be a lot of data QC. You have to inspect your data and make sure it's of optimal quality. And that's what you have to do because you can't build machine learning models with missing values. It won't work. You get them here. So all these missing values, we need to address it. So this is looking at all the columns, the 52 of them. Yeah, then this is plotting the sale dates and the date and the price. And you see that this plot is too sparse. It's not well, it's not optimal basically. So this is the sale dates on the x-axis and these are the prices using a scatter plot. So we optimize that data. Then this is just me becoming one with the data. So when you get your data set, explore it, find gaps, find insights, become one with your data, understand your data. That is the first phase that you have to do. So here now you have the DFC price plot it's the histogram of showing the sale price, which is our target variable. And yeah, that's just basic visualizations, me trying to understand the data. Then here we are passing dates. Now, when you are working with problems, be it classification or regression, that have dates, right? And those dates affect the value of your target variable. It's called time series data. So when we work with time series data, we want to enrich time and date components as much as possible. So you can do that by telling pandas which of our columns has dates in it using the pass dates parameter. That's why I use it. The sale dates, which is this guy. Where are you? So sales dates. Thankfully, we have no missing data there. It's 0. So here now, I'm telling pandas that this is a date time column, right? So give it date and time components using this pass dates parameter or argument. So now after doing that, when I check my data again, you see that is of this data type NS, M8MS. So now if I check my sale dates, he's checking it. This is the first 1000 rows. This slicing that we looked at, straining down this slicing. So you see that this is now a date time object. Date time 64 NS. If you check what was sale date before, you see that it was in date time. If I check df.info sale dates object type, but now we made it date time by using that pass dates parameter when importing our data set. So now this is the normal df.edge, df.transpose. When you see df.edge.t, we are transposing this now. We are making the rows the columns and the columns the rows. That's what's going on here. So these are the columns so that you can see them in one view. That's why I did this. Because when there are 51 columns, you see they are truncated. See here, this is the truncation. Oh yeah, all the columns are listed out. It's now your something that we truncated. Your rows, which you don't mind. So now this save dates now, more inspection on our save dates column because it's time series. So you see the dates now. We have 2005, 2010, 2007, 2007, 2004. We have the year, months, and day, basically. That's what we have. So now we want to sort the data frame by sale dates. I do that by using these sort values. Here, the sort values, then specify which column do I want to sort this data frame by sale dates. So now that I sorted, you now see if I call it df.saledate.edge, you see that everything now is following in chronological order, starting from 1989, 01, 17, 31, 31, 31, 31. This is following in chronological order. And if I check my df.edge now, you see that, see my sale date here. It's following that order. So now I've sorted it in chronological order. So yeah, what I did was to make a copy of the data frame. I made a copy of the data frame because I want my original data frame to be intact. So all my experimentation will be done on this copy. So I called it df underscore temp. temporary data frame. That was the idea. All right. So this is now breaking down that my sale date column. I'm breaking down it down to have more granularity. So I'm breaking it down into year, month, and day using the date time DT. So df dot temp df underscore temp dot sale date dot dt dot year df underscore. So now this is me doing it here. So sale year is equals to this. This will return the year. Df underscore temp dot sale date dot dt dot year. This will return the month. Dt dot. So to return any, if you want to do that, just use, where's my, anytime you want to return something, because this is date time, dt. So if you do dt dot year, to return the year, dt dot day, return the day, dt dot month, return the month. So whatever you want, just specify it. So yeah, even you're giving it more datetime parameters, and that has been affected here. So now that I have all of this now, all of these guys, I now drop sale dates. Remember, sale date was just normal dates like 2011, 10, 31, something like this. But now I have the year, the day, the month, the day of the week. Is it Monday? So I don't need sale dates now. I now drop sale dates. Because now I have them in more granular, more detailed fashion or manner. All right. So this is now checking. These are the states. I'm expecting the states. How many bulldozers do we have per states? And this is what we have here. This is for examples. This is just, I know I'll get an error. We've done enough EDA, we could always do more. Let's start to do some model-driven EDA. So from scikit-learn, random forest regression, so I've seen this. Now, when you specify n jobs equals to -1, this is telling it to use a lot of resources in your CPU. It's telling normally by default, n jobs, I think is 0, 0 or 1. When you say -1, you are assigning more computational power from your CPU to your model. That would, since there's more computational power, it will run faster. Because believe you me, models can take 2 to 3 hours to run. Some even longer. I ran a model for 5 hours before. So that's the essence of this -1 now. This took like, I've forgotten, but like, didn't take up to an hour, like 30 minutes or less, 20 something minutes. So yeah, you see that I'm trying to use random forests and trying making this sale price my target variable. Wait, yes, this X is dropping the tail price. So everything apart from my sale price is my input features, and this is my target variable. So fit it on the model does fit XY. It's the same thing as what I've done here. All right. So now you see that could not convert string to float low. So I still have to do some conversion before I can be able to build my model. So I come here, I check usage branch data type. I see that is O. D type O means object. And I come here, I check missing values. See as are plenty. And I want to build a model. Am I not whining myself? So work. So first thing I do, I convert the strings to categories. What I'm doing here is pd.api.types from pandas API. Check the type if it's string. This is like a Boolean operator. You remember a Boolean, true and false, true and false. This is like a Boolean operation. So using the pandas API, check the type of this guy. Is it a string? And that's why it's telling me true. pd.api.types a string data type. That's telling me true. You can look it up. The doc is always there to help you. Okay. And here I check there the temp underscore items. So here I want to find which columns contain strings. Which columns are object type. So I just look for label contents in df temp.items. If the um if is string, if the contents. This is the same thing as for X, Y, and df. We saw how to look through a dictionary. So it's the same thing. For key value in df temps.items, if pd.api dot d type value prints the label, is it a string? So all of this that is returned here are strings or objects type columns. So this is what I was saying. If you are wondering what default items does, random dict key one, key two, or key value in random dict dot items, every display key of display value. Friends, this is a key. The key is value hello. This is a key. Key two is what? Hello world. Alright, so this is now checking. This is converting all of those string values into categories or those subjects. So how do I do that? What is doing that is just as type category. So the same thing, df dots for key value for label contents in df underscore temp.items. If pd.api, if it's string, converts it to a category. That's what this block of code is doing. Here, contents.as type category does scatters or that. So now if I call my df temp.info, you see that everything has been converted to categories. So this is checking the states column, which is one of the inputs in our data set. Checking the categories of states that are there, the total number of states. So I think these are 50 US states. So df states dot value count. So you see which states appear the most. See Florida, Texas, Florida 67,000 times, Texas 53,110. You have all of that. Okay. So thanks to pandas categories. This is not important. Well, it is to an extent. This is just looking at the percentage of missing values in each column now in a probabilistic manner. Right, from 0 to 1. So we see that this guy is like 4% of the data set. This one is almost 64, 82% of usage band is missing. Yeah, 64% is missing. Yeah, 34% of the 400,000 is missing. Yeah, and 34% of 400,000 is not small. That is like talking about like 70,000 thereabout. So what do you do in those kind of cases? You can't drop the data. If you drop that row or if you drop that column, you have lost 70,000 data points, which could have helped your model, which could have assisted in model building. Because just because that one is low, that doesn't mean some other columns are missing. Right. So dropping it is not the best course of approach or best course of action. All right, so I saved that data set. This is how to save the temp to CSV, give it the name you want to save it as. So I import the process data. All of this is just elementary. All right, so this is now checking. Now you see that the category, okay, I still have missing values, auction ID, machine current. So now we want to treat these missing values. Few numeric values first. So now this is, remember before pd.api.types is string, but now since I want to check numeric, I'm using is numeric underscore d type, and this returns all the numeric values for me. So now this is checking for the numeric values here that have no values. Remember we created these guys ourselves, this sale year, all these date time parameters. Sale year, sale month, sale day of the week, sale day of the year. First time. All right, so here now we're checking for the numeric columns that have no values. If PD is null dots, and I'm just using a simple for loop, for key value in df temporal items. If the data type is numeric, and if it's not, print that series, that column that has no values. You see that we have auctioneer ID and um, machine hours current meters. So here I'm also using a for loop to fill those numeric nodes with the median. If you remember one of our very first conversations, I asked, why do we use median instead of mean? Does anyone remember? Why do we use median instead of mean? When we're looking at EDA.
Yeah, you said
So-
median is it gives you more of the average values than mean, because mean now if there's like disparities in the range of the values, your mean might be a little to one side than the other,
Yes,
something like that.
beautiful. Yeah. So a very, very granular example. If I have 2 plus 3 plus 4 plus 250, that 250 will greatly affect the mean you will get. But if I'm using median now, it will still return like 7 point something or thereabout. Is a more robust metric for assessing the measure of central tendency. So median is more robust than mean, and that's why I'm using median here. Okay. So for label content in, yeah. So now this is me helping myself here. I'm adding a binary column, adding this label dot plus, adding is missing to any row where it was missing before, but I've imputed with the main. So that is letting me know that okay, this was missing, but I imputed it with the main manually because I can't build models with missing values. So here I'm not filling it. Contents dot fill now with the median. All right. Okay, this is now an example. Demonstrate how median is more robust than mean. So here I have hundreds MP dot full 1000 1000. 100 billions MP dot appeared. So MP dot see the mean is 100. The median is 99. Okay, sorry, the mean is 100 for hundreds between 100 and 1000. Mean is 100. Between in 100 billions, the mean is 99100. For a median, the mean is 100. And sorry, in median, the value is 100 and the value here is 200 because this one is less subjective to skew. We call that when the data is heavily skewed, right? When it's skewed on because of the like was that one lady that spoke now? Not checking. Like you rightly mentioned, because of the range of variability, the mean can be greatly affected, unlike median, which is still more robust. All right, so this is now checking to see how many examples. Remember, I added that dot is missing. So now we see that we had 392,562 that is missing. All of this is just for pure righteousness. Let me go to the main. Right. Think, yeah. So now this is me trying to build the model again. Remember I ran it before, I got error. But now that I run it now, it has run successfully. And when I call it, I had 85%. It's called the model. When I call model score, it gives me how accurate the model is. But why isn't this metric um why isn't it reliable? That's because I'm assessing the model on the training data. So there's no point. The model is not generalizing, it's not learning anything new. I'm meant to test the model on the test data, not the training data. So that's why this score is not um, reliable. So here now, I want to split the data into train and validation sets. So yeah, validation sets are when the sale year is 2012, and the train data sets is when the data is not equal to. So every year before 2012, that is from 1989 to 2011, will be our training data sets. Our validation data set will be the year 2012. Sorry, 2012. That's the 20 I just mentioned. All right, so now I'm splitting the data into X, which are inputs values, and Y, which is our target variable. All right, so here we have their shape. So for the first one, my X string is 401,125, and Y train is 102, same thing. And the X valid is 11,573. So this and this, you can see is coherent. And this and this, you can see is coherent. I'm just inspecting the shape to confirm that I didn't do rubbish. So now when I call Y train now, it returns Y train to the 400,000 thereabout that we have, but it's truncated here. So here I'm building an evaluation function. And the reason why this is underlined is because I'm using pylons, and to tell me that it's deprecated. As you can see here, mean square log error is deprecated. So, but we still have mean absolute error, mean squared error, and the rest. So here I just built a function, calculates root mean squared error between predictions and true labels. So NP dot square root mean squared log, but it's depreciated now. Then Y test and Y predicted. This is test data and this is predicted. So what are we doing? We're trying to check how far off was the model. So Y test is the actual value, right? The actual value. Y predicted is what our model predicted. So we're trying to check the error between what our model predicted and the actual value. That's what's going on here using this evaluation metrics. Then here is to show the scores, right? Show the mean absolute error, Y train and train predicted, actual and predicted, mean absolute error on the valid actual and predicted, value predicted, valid, sorry. The RMSE on the Y train actual and the train predicted, and so on and so forth. So this is looking at the different evaluation metrics, MAE, RMLSE, and R2 score. Now, all these ones, remember, your mean absolute error, the closer it is to zero, the better it is, because when you're checking for the difference between your predicted and your actual, the closer it is to zero, the more accurate your prediction was. So if I say predict the price, so if someone predicted the fuel price to be 1 as at this time, person will be quite accurate. So we want, so when you minus it minus the actual fuel price, what is the actual fuel price currently? Depends on where you're buying from, but let's say 1070. So the error is 30, which is fine. This is quite close. So the error, we want it to be as close to zero as possible. The only thing that we want closer to 100 is your how to score. The higher it is, the better your model. You can see that I said this will take too long. You're working with 400,000 data points. That's why I commented this out. So our X train has 401,125 data. So I'm not training this on 1,000. On sorry, 10,000 data points. Right? The first 10,000. Same thing with the Y train. First 10,000. Because if I run this 400,001, my laptop to carry, but to take an awful long time. All right. So here now, I'm just playing around with the parameters in random forest regression. And what am I doing? Guys, should beg my laptop. There's no time for this thing that you're doing. Okay. So if I come here now, random forest regressor. See the documentation with scikit-learn. What I'm doing, I'm playing around with these parameters. All of these parameters have been run multiple number of times, and these are decided to be the optimal parameters in a base case scenario. But you can, when you are playing around with these parameters, it's called hyperparameter tuning. You're experimenting to see if I put another parameter, will I get a better model performance? And that is what I'm doing here. Okay. And here I just put max samples equals to 10,000 because I'm using 10,000 of my data now, 10,000 data points to train my data. So here I put time, cutting down the max number of samples. See how we can improve training time. So X train and Y train now. See that it took 1 minute and 5 seconds. Before it took me like 32. If I had run this thing, I would have slept. It would take like an hour or two. But now this took me just 1 minute and 5 seconds. So by the time I check X train the shape, then now show scores. You see that my MAE, my mean average error, 5,560. My valid MAE, 7,170. My training MS is 0.25, 0.29. Then remember I told you the closer this is to 100 or 1, because this is 86% now. So that is good. If I had 90%, that means that model is better. My training R square, R2 score is 86. My valid R2 score is 83. So this is a model that is doing quite well. Well, depending on your metrics, at work, you might have told you that they need at least 92% accuracy. So you know that this doesn't meet the specifications. So now I want to improve my model using hyperparameter tuning. There are two major methods to tune your hyperparameters called randomized search CV and grid search CV. So let's look at randomized search CV. So I'm basically just playing out. So the what I'm going to do in this block of code is going to determine, it's going to run a number of simulations. It's not that it's doing it. They're just specifying these parameters initially. But this is going to run a number of simulations that will now, after it runs those number of simulations, it will assess the scores, the model scores when it changes different parameters. So when it's done, it's now tell you the best parameters to use, best values on parameters to use to have the most optimal score. That is the essence of this thing. That is what it does. All right, so here this is the random forest grid. My estimators NP dot arrange from 10 to 100 moving by 10. So that'll be 10, 20, 30, so on and so forth. Max steps, none, 3, 5. I'm just playing around. You can look at doc on this because I don't have time is on outside. But yeah, it's not. I'm just specifying some hyperparameters here. All right, so here I'm now instantiating the random forest search CV model. So when I run this, I also specify -1 because I want it to, I'm allocating more computational power using random state of 42. Params distribution now is this RF grid I created here. Number of iterations to cross-fold, dividing into 5, fitting into 5 folds. Then variables is true. These variables is so that you show me all these texts that you're seeing below. If I don't put these variables, it will just run, it won't show me anything. I don't specify it as true. So yeah, I'm not fitting the model. All right, so when I fit it now, we get all this. It's fitting two candidates. So CPU time, it took 6 minutes and 35 seconds for this to run. And when I now look at the best parameters, that for the best parameter, I'm saying use 50 estimators. Use let your mean sample space be 10, your mean sample space be 11, max sample of 10,000, max feature use square roots, and max depth of none. So now when I evaluate this model, I'm having a this didn't do too well because I'm not using these parameters yet. But I'm having 70, 71, and before I had 86 and 83. But now let's use these parameters I told you. These N estimators. Train a model with the best parameters that were found after 100 iterations. So I did this at the back. This was 2 iterations, right? That gave me this, but this was after 100 iterations. So that's the best estimator to use is 40, mean sample leaf of 1, mean sample split of 14, max features of 0.5. These are allocating more computational power, CPU, max samples of none. So when I fit this guy, when I call it now, you see that I have a increase in performance. It's now 88 from 83. So there was a 5% increase. And this one was 86 before, it's now 95. So it increased by 9%. But it's a valid that I'm more interested in. 88%. We are closer to the metric. Our guy will not vex. We'll give him like this. Best we could do is 88%. All right. So make predictions on the test data. So now we are now going to predict based on that test data. So I'll get this error because I added these dots is missing manually, right? So I have to make those experimentation I did on my training data. I have to do it on my test data. Everything has to be the same so that I can perform the same operation on them. That's why I'm getting this error here. All right, so that thing that I did, so I gave it, I added those is missing. This is my test data. All these things I did before was on my training data, but now these are my test data. So now I gave it all those date time parameters, sale year, sale months, day of the week, day of the year, and all of that. Then I also added all those dots is missing. Functional is missing. I use the sets to find the difference between my train columns and my test columns. So yeah, so I did all those. I processed my test data, so it's been the same format as my training data, so I can make those predictions. So now it worked. Yes, I can make predictions. So here, when I tested it, test spreads ID model does predict my DF tests. So how is this one showing here? But this is not an error, sha. Okay, stats information. It's a warning. All right. So this was formatting the predictions into the same format that Kaggle was after. So this is the sales ID and this is the sale price. The predicted price. This is my DF predicted. This is my um, predicted price and this was the sales ID. So I saved that. Then the last thing I now looked at here was feature importance, which had which features contributed the most, or which feature affects the target variable, which is sale price, the most. Which of these features or attributes of the data were most important when it comes to predicting the target variable, which is our sale price. Right, so I plotted this helper function to make a visualization to show me plot features. So see, I call it plot feature, then I put else in those columns and I them. So anytime you use random forest regress or classifier, you can always get the feature importance. So it's a method of whatever model you use. This was the name I gave my model, ID model. Your model might be Blessings model or Lawa's model or Olamide's model. But this was my own model's name, ID model. So if you call ID model those feature importances after having your model and doing your team. So I plotted this against the columns and it showed me importance. So here you see that year made contributes or affects the price the most. It's like the most important feature, followed by product size, then the enclosure, then the sale year, then all of these other parameters. So showing it in so from descending order of importance. So this was just checking product sizes. So medium, large, small, mini, which is you don't expect a mini bulldozer to be the same price as a large bulldozer. So that is fair enough. That was looking at all of this. So yeah, this is typically how machine learning is in the real world. You have to account for all of these nuances and intricacies. And that was the purpose of today's class. Now, I'm going to ask a question which I should have asked a long time ago. Do we have questions? I wanted to do that and this today, but time is not on my side. Before I go on, do we have questions? I said a lot. So ask me questions. Okay, do you understand? Guys, if you don't want to talk, at least send the emoji. Because time is fast spent. Okay, thank you everyone. Ask questions. This might be our last call. Okay. So what we just finished looking at is a feel free to interject if you have questions. What we finished looking at was a regression project. Now this is another project entirely. All of them, both of them are well commented so that you can also go over it in your due time. But let's quickly look at this guy. So we're trying to predict heart diseases using machine learning, right? So the objective of this is that we want to know if a patient has heart disease or not. So what kind of problem is this? Trying to see
Very classification.
the expo is showing here. The classification problem.
Classification
We're trying, yes, it's classification. We're trying to classify whether something is true or false, yes or no. Will the person have heart disease or not? Right. So for in the long run, if you are trying to predict if something is yes or this or that, that is a binary classification problem. Binary classification. But if you have more than two things, so yeah, if let's say you're trying to predict if this is cat, dog, or lion, that is not binary again because it's not two things you're trying to classify, it's three. So we call that multi-class classification. So there's binary classification and there's multi-class classification, which is essentially classification of things that are greater than two distinct types. All right, so trying to predict heart disease. So in something like this, you have to talk to your domain expert if you don't have a medical background, right? Well, I try to explain the features as much as possible, and I sent the data set for this to the group chat and CSV format. So here we have the age, the sex, CP. These are different features that we have, and these are explanations. So just like the last time, we imported guys tools that we're going to use NumPy, Pandas, with their corresponding aliases, Matplotlib, Seaborn, all of them. And this is importing models. I imported logistic regression. And then you'll be asking, are we not doing a classification problem? Why are we importing logistic regression? Now, logistic, not linear. Logistic regression is actually a classification model. So it's actually is for classification. It's linear regression that is a regression model. So logistic regression is actually a classification model. I know this guy is random forest classifier. Okay, you remember we have seen random forest regressor. Now let's see random forest classifier, like k-neighbors classifier. There are also other models. All right, so this was loading the data. This one is not as dense as our. This one has just 303 rows and 14 columns. When we finish that, more than 50 columns and 400,000 rows. So this is less dense. Right. So we start with our EDA, inspect the data, try to become one with the data. Then we look at the targets. Here's the target. One means yes and zero means no. That's all we see here there. Let's find out how many classes are there. The target of value 1 0. So we'll now plot them. This is 1, this is 0. And we check their data types, and if they are integer, this one is good. Check if it has missing values. See that this has no missing values. That's why I didn't do this first. Right, then you look for the heart disease frequency according to sex. This is just some basic EDA, exploratory data analysis, visualizations, trying to become one with your data, right? So yeah, I now I'm looking and investigating the relationship between heart disease and gender. So here you see male and female, right? And you see that the male have more tendency to have heart diseases than the female. So this is if this is no, there is no disease. So if they are male, they're actually more likely not to have an heart disease. This is just a body. You can still validate this using techniques like hypothesis testing and all of that, which unfortunately I won't be teaching. But I can send resources on how to perform hypothesis testing. There are numerous online. Right. So this is basically me doing exploratory data analysis, understanding my data, and trying to become one with it, investigating the relationship between maybe two parameters or multiple parameters and how they affect heart disease, if that patient's going to have heart disease or not, looking at their sex and other um, input features that we have. Yeah, that is what we have here. This, and it's important to do EDA in any form of machine learning projects or data science projects you are working on. EDA is a crucial part of the workflow. All right, so this is creating a correlation matrix, df.score. Right. So I now made it in a heat map manner. So you see that age has a correlation of 1, as you'd expect. Sex and sex correlation of 1. That's why I see this diagonally. Everything here we have a correlation of 1. So I ask him what's the correlation between blessing and blessing. It's blessing has a correlation of 100. But here you now see the other correlation 0.28 minus 0.17. So you see you have negative correlation and positive correlations in some places. All right, so to modeling, we first drop the targets, right? And X is everything without the target because that is our training data. We're trying to predict the target variable, which is Y. All right, same thing, we break them into train and test using train test splits. That we inspect how many training we have to 42. Right, so here I just put the models in a dictionary. And I just looked through them to see which one is performing better. So, and I now built this helper function to fit and score the models. So I see which one is the best performing. So at the end of the day, I see that logistic regression has a score of 88. KNN is the worst at 68, and random forest has 83. So logistic regression is the best performing model. And this is just a plot showing the comparison of all of them. See logistic regression, there is accuracy, followed by random forest classification, and the worst is KNN. So this is trying to improve with using hyperparameter tuning. Right. This is trying to improve the KNN model. That's the KNN, not all three of them. Let's see if we can do better with KNN. So now the KNN improves from 68 to 75.41. That is progress after tuning it. So now this is trying to optimize the logistic regression model with hyperparameter tuning and randomized search TV. So just like we saw in the Bulldozer price prediction project, it's the same thing. Logistic regression, the grid is this guy, RF grid. Sorry, the grid grid, this guy. Is for my logistic regression. 5 folds, 20 iterations, it goes through. And these are the best parameters. Use a solver of the linear, have a C of 0.23, blah blah. Right. So now let's build a model with those parameters that they told us now. Oh, this is for random forest, sorry. That's for random forest. Okay, because of time. Then this is grid search. So the two major ways of optimizing your model is that using grid search CV or hyperparameter. The two major ways of performing hyperparameter tuning is either using random search or grid search. So this is also how to use grid search. They are very similar. So that is an assignment for us to go and do research on it. All right. So after doing that, we see that which model score is this one? This is logistic regression. Starting research 88. That one I had before. Your day is trying to make predictions based with your team model. This GS log reg. This grid search logistic regression model. That's what it stands for. Most of the time, I won't be able to explain what ROC and AUC mean, but there are some evaluation metrics that we use in classification problems. So just like we've seen the evaluation metrics we use in regression, we've seen MAE, MSE, RMSE, and the rest. For classification problems, we also have evaluation metrics, accuracy, F1, recall, AUC, ROC. Those are evaluation metrics that we use for classification problems. All right, so I'm going to share this slide. Okay, I shared the notebooks already. So you can actually just go through them because our time is fast spent. Right, and they are quite detailed. So you'll be able to tell what I'm doing, what's going on. Make sure they are all commented and explanatory. So I'll share this slide so that you guys can peruse it. But now to the last action of today. Okay. So we are nearing the end of our program together. This might be our last class. I don't know if Israel will be available. So your final project is to build a machine learning model on either let's use Spacesuit Titanic. So this is the link. I want you guys to build your models on this or do this either using, I like using VS Code. You can use any notebook if you know how to use Jupyter or Google Colab. Or Colab can be messy sometimes because of the way it has been acting up this year. But yeah, this is your final project. Build a machine learning model to predict which passengers will be transported to an alternate dimension. So the overview and everything is here on Cargo. So you can actually, I will send you guys my um send you guys those notebooks. You can use them for references and to help along the way. So we need this by Thursday because the bootcamp is ending officially by Thursday. Right. So I'll try and make sure that this recording is sent today to assist you. So just is everything we've learned so far. We are applying everything we've learned so far from we went from the ground up, from the basics and we're adding increasing layers of complexity. So that is all you need to pass or do this project. Let me run away from here. So yeah, at this point, I feel I've been the only one talking. So any questions? Any questions? Any questions? Any question, guys? Listen, I didn't hear you. Please come in.
Like, how are we going to submit the project to you guys?
All right. So you can either send it the way I sent mine. You can send the data, right, and your notebook, or you can share it in a Google Drive. You can upload it on Collab and others. Give us access to view
Please, when do we submit?
it. Thursday. Today is Monday. Yes. Tuesday, Wednesday, Thursday.
So when is it?
Thursday, Thursday. Ramon, what do you mean by that emoji now? That a good or bad thing? Oh, well, yeah, it's been a lovely journey. So by Thursday, I want you guys to, as you are trying to, if you run into any problem that is bugging, put it on the group chats. You guys should collaborate and resolve it together. This project is the essence of this project is to test your understanding of all the concepts done so far because you're going to be using practically all of them. Test the concepts of all the concepts, test your understanding rather of all the concepts done so far, and to also own your machine learning proficiency. So if you are done with this project, we'll move on to the next phase. You won't be teaching that because the boot camp is, but I'll be sending resources that you can use. And trust me, I have a lot. Because what I've looked at now is traditional machine learning. There is now deep learning, the ChatGPT, LLMs I have seen. They are a subset of deep learning. So deep learning is largely divided into two. We have computer vision and we have natural language processing. So your LLMs, your large language models, they are under natural language processing. But because of time, we can't, there's no way I can teach you LLMs in 8 weeks. Even 2 months might not be enough. It's not even my field. My field is more CV, computer vision. But I have many resources for you guys when you finish your project. And my last that's a call to action that I want you guys to do is join as many communities as possible. Right? Any data community that you see, join. When you are part of a community, it's exponentially increases your chances of success. You get to network with people, and these people can put you on opportunities. It's just like a scenario when it's only that is applying for a job. It's just only when you're in the community, there are resources, there are thousands of people who can send you links or new jobs which you never have found if you are on your own. My first job was from a community. So I would really advise you and encourage you to join as many communities as possible that tailor to your field. We're going to be joining um, marketing when you're not doing marketing community. Join communities that you're interested in. So you know you're interested in data science, machine learning. There's GDSC, there's MLSC, there's data community in ELAG, there's machine learning Lagos. There are lots of communities out there. So join communities that tailor to your field of interest. You get to meet really exciting people, network, and you are basically just at Data Fest. They said you are you are almost fast tracking your life by like 30 years because you are exposing yourself to an exponential number of opportunities. So that's my last words to you guys on the group chat. So anything, but again, I feel like I've been talking so much. Any questions? Any questions, guys? Feel free to shoot. Though. I've said a lot in the past 1 hour, 25 minutes. Ask any question. It doesn't have to be technical. Be a very generic question. I want to hear you guys' voices.
Join all this community.
Listen, what do you say?
I said, how can where can we get like links to all those communities?
Yeah, I'll send the ones I have. Yeah, I think you guys are already in MLC. So there's GDSC, there's data community in LAC. I'll send the links. You guys remind me too, please. All right, so any question? Last time I'm asking. Any question? All right, so in the absence of none, and for possibly the last time. All right, guys.
Bye.
Thank you. Bye.
All right, guys.